tools for what we have to do. The coding can be in some ways helped by using the aluminium foil, putting a little bit of it, it will activate the coating as well. So if you add some potassium to the caustic, so you will have potassium that will help for the coating, and adding aluminium will help.
So we can begin now perhaps with just the official opening of this workshop, which is the first Knowledge Seekers workshop coming from the Spaceship Institute part of the Keshe Foundation. And we have some of the knowledge seekers from the Spaceship Institute with us on the Skype line, as well as some people over quite some period of time in the Keshe technology. So, in the first part of the show, the first hour or so, we'll have mainly comments from the people from the Spaceship Institute, delivering the information that they would like to put forward at this time. And then we'll have more of a question and answer session after that. So, I will turn over the conversation to the people from the Spaceship Institute. And if you'd like to introduce yourselves a bit first, and then we can carry on.
So, do you want us to each give a small introduction of who we are?
I think it'd be great if you'd each just say who you are and a short thing about maybe why you're there, and then we can carry on after that, sure.
Okay, ladies first. So, hello everyone. I'm a knowledge seeker from Japan. My name is Yukako. So I was in the 9th workshop, so some of you probably we already speak each other. And then I'm currently work mainly about the Fukushima issue. So we already started the nanomaterial to send into the Fukushima NPO. Several NPO gave us the contact since last workshop. So at this moment we are in preparing stage, but I hope we can send it by the end of month to start the examination in Japan. Thank you. I pass to the John.
Okay, my name is John Skelton. I'm coming from Belgium. I was born in Africa, so I have links in different areas. I'm interested in the opening of this knowledge because it goes in this straight way to follow what's my understanding of matter, of knowledge about universe, and this is a new opening in new areas, and I'm very happy to start this knowledge seeker, and well, I'll be there for helping each of you to understand what my knowledge is. I have to give it to you, so that's my position, yeah.
Hello, I'm George. I'm the Spanish speaker from Knowledge Seeker. I was born in Spain, and my purpose is to share knowledge and to serve humanity.
So anyway, I'm Marco. I'm coming from Slovenia, and I'm also knowledge seeker. I really like to participate in this group, which is a group of scientists from all over the world, and this is the way that people should cooperate in the future. Without any borders, no matter which language people are speaking. the intention is more important than language and the country which we are coming from. And I'm glad that I can cooperate with knowledge seekers from different parts of world. And I can say that we are living together without knowing each other before. We are living more or less in one house. So I hope that also other people around the world will follow this way of cooperation. Okay.
Armin is not there, so he'll have to introduce himself, maybe, but I'll give a few words. He's from the United States, LA, and he's very happy to be with us also as a knowledge seeker. So we are waiting for him, but we can start. He'll be coming probably soon.
Excuse me, sir. What was his name?
Armen.
Armin.
Ahmed.
We have still other knowledge seeker. He is not here with us. From Belgium, Ivan Michel. And he spent some time in Belgium and some time here. And we shared whole weekend. He's a dentist. He is a dentist in Belgium.
We have a common person. We know each other through a common person.
Right. Still, we have one knowledge seeker. His name from our application.
We have a knowledge seeker for Africa. We have a knowledge seeker for Africa. Build to understand the physical part. And hopefully it will able to be complete as a big group. Of course, my name is Keshe, members of my family. And from what we have seen in the past 3 weeks, we will launch a new cycle of knowledge seekers for the next couple of months, which means we're going to have bring in the second group of knowledge seekers on. So I leave it to the rest and we don't talking. Carry on.
So, at this level, are there already a few questions happening, coming up? No, my question, ask of question would be rather now at this moment, if you have any question about one of us. Sir, no question?
Well, I can ask a question if no one has a question. I feel that what you are doing is groundbreaking. It's a great forwardness on the part of Mr. Keshe to educate people. This is new school teaching. Mr. Keshe, I was privileged to listen to Mr. Keshe from the beginning of his workshop. And he has given a very instrumental information and as people thinking with their head on a different way about the universe and about the body. And I hope that people that are going to listen to you and your groups seeing all these new way of thinking. Am I right? That's what he's doing, all of this thing?
Well, it's a progression because things have to be understood, and the way of doing the things slowly at the beginning happens to become faster and faster. We are understanding, we have started understanding before coming here. We are progressing fast in the way we are doing things now. Soon we should be even able to fly the reactors. So that's something that is going to be happening quite fast now. So we are there because we like to learn, we like to give of our understanding. So we'll progress, we'll go forward. So you see, it's not new aspect, it's the following what has been done before.
Yes, I agree with you, sir. It's not new, but it's new to people that have not listened to Mr. Keshe. And Marco, I know Marco quite well. Hey, Marco, hi, it's the dragon, dear. Marco from Slovenia knows me very well, and I'm so glad that Marco is part of your group, because that's the point of the more people can learn about the new technology, the more people can educate people of the new way of thinking, of this way from different thing, they think different way of different background. It's very important also that I've seen everybody has different type of language, which is something of important as well. Wouldn't you say, sir?
Absolutely, I agree with you. We should have as more as possible language speakers here, as much as possible different knowledge speakers with different native language speaking groups. And the aim of this station institute is to learn new understanding of our environment, new understanding of physics, and to pass this knowledge to all the people around the world. This should not be just for let's say, small group of people. Everybody should be learning this new understanding, this knowledge. And we will try to pass all our experiments, all our everything that we learned, we try to pass to internet, to people who are teaching to learn. But we can pass this knowledge, but also we need support from outside. So it should be put some effort from people outside to learn this. We can supply support, but it is the choice of other people to participate in this part.
Hello everybody, my name is Armin. I think you all know me.
Morning, Armin.
Hey Armin, how's your tooth?
Oh, it's gone.
Oh,
Thank you. How are you looking at me?
good to hear that. Good.
Hello, Amran.
I'm sorry.
Sorry, dear, but the voice was very muffled from the answer. I could not hear the answer. Not on mine, but everybody. And I think that you had something of importance to say, so I think maybe you should have the people repeat it because it was audible air.
Oh, doesn't matter. Everybody over here, they think the same, and whatever we say, it's from all of us. And, it's a tremendous feeling when you understand the technology and you and the point that you want to pass it through, because this technology, it's not only for us, guys. We are over here to learn, and details pass it every single time when we meet. And please, what I'm going to ask you to do the same. Because if we hold this technology, we're not going to come to the point to true understanding. And the whole humanity should be thankful to one soul that it passed it through. And we all know who is that soul.
Thank you. That's a good point, Armin.
So it's I don't know what's happening there with that noise. So let's go through the next part, the most important.
Where is Buscadores?
I have a last question before I will stop my questioning. I know there's a big interest in Europe and Asia that you have spoke about. What about the United States? Besides all of us guys like me and Rick and Vince, where do you see an interest in the United States? And do you see seeing that the way to go is peaceful and stuff like that? Do you see that?
For me, it's no difference United States or whole world. You know, and every government side, you know, people who understand, they should come together. Because this technology is not to solve for a small group. The group, it should be so big, so huge, that it can happen instantly. And we are asking guys to write your government representatives, scientists, to spread the word that they can come together. This is the only way. If you can understand, totally this technology is so simple.
Well, I would be adding one aspect which is for me very important. Technology is one aspect of our life. What is the most important is what each person on the earth will choose. And the key factor for me is love. We have to understand what is love, what is loving the other, what is in fact the main aspect we have is the gift of ourselves. And that's what has to become a main axis in the understanding of the whole humanity, which is one, and we all belong to that humanity. Well, we have to get out of the Middle Ages and start looking at the real energy of love, which has to become something that each will understand. And if you feel love, you cannot resist.
Well, of course, that's the way to go. Mr. Keshe, you're there and you hear me, and you know me, I'm always feel that love is the way to go. I mean, you can have the best advice that you want, but if you don't have love behind it, it's not gonna work the way you think it's gonna work, right? Am I correct?
Yes, yes, in a way. I am too far.
Oh, yeah, well, I'm sorry, I'm ahead of my time. I'm sorry, but I believe love is the way to go. You know what I'm saying?
I'm a listener today.
What?
So I'm just a listener today because I do enough talking. So what the whole thing goes, I was in a meeting yesterday.
Yes.
And it was an amazing meeting with officials. And when I told them my technology belongs to your nation free, literally one of them, doctor, fell off his chair, because everything to him had a value and something to pay for it. And when I said this is how the foundation will work, he said this cannot be understood because we have to pay for everything. And when I said to him we're given the generator development freely to the Italian nation, to the Italian company, and the condition is that no parts can be made out of Italy, has to be made for Italian by Italian. They said you're changing the course of humanity, and I said that's the whole purpose of the foundation. So I think the group here exemplified the whole thing. That we are here to serve, and each one of us in our own way. And I'm gonna shut up because I won't stop.
And as I always said, you are a very gracious gentleman because you always answer my question to the fullest. Is that right?
I don't know.
Yes. I have special question and you answer special thing. And on that note, like I said, it was my last question. I must say I have to let you guys go because it's 2:30 in the morning my time. But Mr. Keshe, I will be there in your next thing, and I will be working very closely with Diva to put everything that we have said into motion. So on that note, I wish everybody a good night. Good night, everyone.
Very good night for you.
Good night.
Thank you very much, Lady Dragon, for your comments
Bonne nuit.
and your support.
Sure. That's why we are here. Okay. I'm Keshe from the Netherlands group, and I've been busy this week for the copper plating of the inside of the core, and it's looking very good. But Mr. Keshe said make a how do you say between the two half cores, make a contact for the nano layering. Otherwise, the two halves won't communicate. What kind of connection does he mean? With a wire or the nano layers connected or something?
If you use copper and you directly make the layering on the copper, the layering of the nanomaterial, the same way you make it with the wire, then the space would be not connected. So it depends on the way the system is made. For example, if Geert would like to use the copper foil nano-coated, then the contact would still be there between the two spheres. The contact disappears when you make the coating on the copper because they are put in the caustic. If you make, first of all, the copper foils nano-coated and you glue them inside your reactor, the contact of the two spheres, two half spheres, will be maintained. So in this case, this would not be a big problem. The contact is already there. Have a look at the last picture that has been sent.
Yes. Yes.
So see, this, as you are working together with here, this will be a help for you. Because this
The last thing you said, I didn't understand. You went away.
It's a help to Gert, and as you are working together, well, you can help him to understand. Just see at the last pictures that have just been posted on the link.
Would that be number 4463 that we see up right now, for example?
Yes, that's what you see now. Back in this case, it's the plastic sphere, but the foil is another coated copper foils all glued. So that will be the same that will be used.
So basically the two nanomaterials need to be connected.
Let me explain one thing. Nanomaterials only covering the matter. So the curtains are over there to cover the matter. So the plasma, not see the matter at all. If the plasma touches the matter, it will disappear. So the curtains are over there to cover it. So you have to cover all the matter the way that the plasma not going to touch.
Okay, so in this case,
and when you're gluing it, little bit like in the middle of the sheets that, the glue will not leak to the sides because it's important.
so basically if you have two spheres with a flange and you cover the flange too, that's supposed to do the job.
If you see the pictures, there's two spheres,
Yes,
two halves, and you see the curtains that it's been glued from the side. So when you're closing, the globe, it's like, you covered with nanomaterial. So there is no matter. So when the gases enter there, it's when the plasma opens, it's not going to touch the matter. So you're going to maintain the plasma. Okay?
Yeah, that's what I'm saying. If you have two half spheres and there is a flange on them, and if you cover the flange too, the two nanometer flange.
You don't need to.
No, if you do that, you would have more leaks because you wouldn't have two half that could be completely seen together. So you have to be careful not to have leaks. So have the flatness of the flange. They have to come together. So the sphere will be completely seen.
And you're going to put the silicone.
You see that there is one half of the sphere is kind of nano-coated copper foils coming out of the half sphere, and you don't see that on the other half.
Right.
You see that? Well, halfway does nano-coated copper foils come out, have to go into the other half sphere when we close it.
It's like curtains.
Okay, but just is to cover when you close your two halves with the silicon, if you get any silicon going inwards to the center of the core, those curtains which we made will cover it, so the plasma does not see matter. That's the purpose of it.
But are the upper and lower parts actually physically connected by the copper substrate material? Like, do you have to scrape or otherwise connect directly?
The vacuum, this bit of copper which is sticking out on one half behaves or is used for two purposes. One is to keep a nano layer in facing the plasma, which makes it easier to break it up and contain it. And the second purpose of these skirts is when the core rotates, it creates a dynamic plasma because these are loose. So on the fringes allows and creates a turbulence in the outer layer of plasma, which gives the plasma the rotation. Because I have seen, like with the reactor from Marco, he's using smooth stainless steel for two cores, inner and outer. If you have a very smooth surface, how are you going to create rotation in your plasma? The reactors need flanges, or they need indentation on the surface of the core, inside and outside, or you adjust or add wings to your central part, or you make shears or kind of wings internally to create that turbulence which allows the rotation. The smooth reactors like stainless steel with no wings on it or whatever, it will be very hard to rotate the plasma. It's a smooth surface rotating. So what's the purpose of these copper skirts is to stop the silicon when you close the two halves to come into the reactor to be seen by the plasma, and secondly creating a turbulence. I would like to explain two things with these reactors, what you see. This reactor in front of you is a gift from Iranian government to the world. These were made in Iran by the Iranian scientists, and this is part of the original reactors which flew anti-gravitational system in Tehran. So what you see there is a combination of what's been developed, and what you see on the other hand, the copper layers which has been glued on. This is the mystery which I've been telling you for some months, that if you have two mobile phones anywhere in the world, you can create as much energy and food and whatever you like, even lift, with the two mobile phones. And everybody thought it's about to do with the microwaves and the rest. No. The secret is here on the table. You open the two batteries in your mobile phone and use the copper foil to cover anything you have and create a rotation. And that becomes the source of your water, energy, and everything else you need. Everybody was looking how the water is going to drip off the mobile phone that they can have water from it. But this is the secret. This is what's sitting in front of you. You open your battery, you wash the copper foils of your battery, you put it in a caustic, it comes nano-coated the way we showed in the Fukushima situation. You cover two copper bowls or any bowls, even a plastic or clay the way, or ceramic the way John is doing. That's it. You can start absorbing energy, creating things. Use a Coca-Cola bottle to create the hydrogen for the feeding of it. So in a very simple way, what you see in front of you is a total knowledge of humanity. Everything you need. And as I said again, it's manufactured by the Iranian scientists, engineers, and the skirts put by Czech Republic scientists. The other half is done by the American Armenian. And very soon will be tested by a bunch of scientists from all over the world. This is the beauty and simplicity of this technology.
Mr. Keshe, are you talking about the current picture that I have up, the 41.3, would that be an example of what you're talking about?
Yeah, the two halves with the skirt on it, yes.
Oh, that one, okay. There's another one I've got up now.
This is the same picture in two different halves.
So it's covered on the inside and the outside of the reactor in this case?
Yes, because this is the inner part, this is the inner core.
Right.
Yeah? So it sits in another core. So if you look at it very closely, this is the inner core, separation between the Carline core and the outer core. So you coated both sides with copper oxide from your mobile, and as you see it, you can, if you look into the picture, you see black material and blue or green. This is a different layer of oxidization of nanomaterial, different type of it, and you need this mixture. The only thing is, when you touch these materials, you have to wear protection gloves or protect yourself because these nanomaterials can go in your body, absorbed by the blood. So this is one of the things you have to watch, but this is the beginning of what you call it, the anti-gravitational system, or what we call the maggrav system, energy system. If you operate it the right way, you can produce any material from this simple reactor. This reactor, in conjunction with its outer core, I don't know if Marco can put a picture up, this is one of the first series of flying reactors in Tehran. So we know it works, we've seen it working, I have tested it myself, and so many times I had to catch it when it flies in the air. So it's a lot of hard work. What the skirt you see on the half, I think it's taken Marco about a day to do it. It takes time, you have to glue it properly, and then that's it. This is a copy of the Earth, and it can give you whatever Earth can give you. Energy, water, material. We start teaching how to operate it to produce what you need. So, maybe as a joke, but as a reality, if you were waiting for your mobile phone to drip gold out of it, now you've got it. You've got what to do with it. You can use the keyboard as operational control, but you need the copper foils inside your mobile battery to be able to condition the environmental and the environment of nanomaterial or GANs that the plasma is comfortable with because it's made of the same thing. The reason this coating is on is because nano layers are more or less GANs layers. They are in a spherical energetic level. So they are the same as what the plasma is opening into. So it's comfortable, and you can do all sorts of games with the plasma. I'll leave it to the rest. Sorry to interrupt, but these things need to be explained in the steps that people understand. And as we have opened the technology, we are not leaving anything out. There is a key missing. There will be nothing missing, and we explain everything, and the knowledge seekers, according to their understanding, explain what is going on. But this is what we say. This is an international collaboration, and I have asked if it's possible by end of March that we have the first flying system or the energy system here in the Institute built by the knowledge seekers shown to you. As you see, everything is open. This is the lab where they are working. Everything is whatever is available to us is on the table. Thank you very much.
So next quick question, guys. Do that layers are created by different chemicals, or
You have to repeat the operation of coating. It's by multiplying the layering, just as it has been told for Fukushima. You make the first layer, you put it in caustic, You get it out 24 hours after, you leave it in the damp atmosphere. After that, you'll have the first coating. You put it back into caustic and you repeat the operation. Repeating the operation will put up multiple layers, and those multiple layers will vary in the size of the holes you have in the layers, and you'll have a whole spectrum of fields that can be used. It will be captured, that will be in fact happening to help the creation of the plasma condition in the reactor.
I'm asking this because I play only with wires so far, and I never got the green covering. I always get the black one. That's why I'm asking.
After you have made the coating, you have to slowly open the box so the material can dry. The drying has to go very slow. So don't bother if it's turning black. The green color comes from later, and that's the atmosphere.
Are we connected?
Are we still connected? You hear us?
Good morning, John.
Hello, Dave.
Dave here. What material is the plastic housing on the spheres? Is it PET?
Doesn't matter what material you're gonna use.
Really?
Still you're gonna cover it, correct?
Yeah, with the copper on the interior?
Huh?
With the copper on the interior?
Yes.
Yes, you take small pieces of, as you know, the batteries of the cell phone have to be counted, and you just take scissors to cut it into pieces that you each, and all those pieces have to be glued. So, I see your question here, how to open without hurting ourselves. Well, you will take glass and be careful at what you do, and you have to first open on the side, and when you open on the side of the battery, you will have a piece coming off, and afterwards you can completely, just as you would open the sardine box, sardine can, just open it, and once it's open, you'll see that the copper foil is rolled in a flat shape, and with one foil of aluminium, one foil of copper, and in between you have a black chemical that is not of no use for what we have to do. The coating can be in some ways helped by using the aluminium foil, putting a little bit of it, it will activate the coating as well. So if you add some potassium to the caustic, so you will have potassium that will help for the coating, and adding aluminium will help also.
I have another question, if I can. I sent a picture from my copper layering from my course. So maybe if I nano coat the inside like it is now, and I glue a skirt to cover the seal between the two. I believe this will work too.
Yes, this could be very well. Well, what I see from your picture it is quite interesting to see that the copper that is coated on your stainless steel is covering correctly and uniformly the stainless steel. So another coating would be a good way to go, but you should have you should be careful in the way you do it, not to have bubbles being trapped. If you put your reactor, your half phase upside down, you would have some bubbles appearing inside. So try to have it put sideways, so no bubble should be trapped.
Okay. This week I make a video with the manual how I coat the copper.
Yes.
Did you use electrolysis?
So if you could explain, because it's for the recording, just explain how, I suppose you made an electrolysis for the coating, so just give an explanation.
Yeah, I take some acid from, how do you say it in English, it's sulfur acid. I make a solution with copper, becomes bluish, calling copper sulfide. Okay. Then I take a power source, and on the positive side I connect the copper pipe and wrap around a cotton ball, dip it in the copper sulfide, and the negative is connected on the sphere, on the half core, and that way I can just paint the copper on the inside. It's very easy.
So
Nice.
just to give the explanation, copper sulfate for chemists would be CuSO4. So you have to mix the copper sulfate in a solution with some acid. And
I make
that's
it myself.
a solution. Yes, this could be very well. Well, what I see from your picture, it is quite interesting to see that the copper that is coated on your stainless steel is covering correctly and uniformly the stainless steel. So another coating would be a good way to go, but you should have you should be careful in the way you do it, not to have bubbles being trapped. If you put your reactor, your half phase upside down, you would have some bubbles appearing inside. So try to have it put sideways, so no bubble should be trapped.
Okay. This week I make a video with the manual how I coat the copper.
Yes.
Did you use electrolysis?
So if you could explain, because it's for the recording, just explain how, I suppose you made an electrolysis for the coating, so just give an explanation.
Yeah, I take some acid from, how do you say it in English, it's sulfur acid. I make a solution with copper, it becomes bluish, calling copper sulfide. Okay. Then I take a power source, and on the positive side, I connect copper pipe and wrap around a cotton ball. Dip it in the copper sulfide, and the negative is connected on the sphere, on the hot core, and that way I can just paint the copper on the inside. It's very easy.
So
Nice.
just to give the explanation, copper sulfate for chemists would be CuSO4. So you have to mix the copper sulfate in a solution with some acid. And
I make it
that's the
myself.
solution. Yes, and that's the solution you have been using.
Yes.
The
But
voltage you use.
Sorry?
The voltage used should be a few volts, I suppose.
Yeah, 3 volts, I think, yes. This week I make a video of it.
How
Okay.
thick a layer are you making?
Sorry?
How thick of a layer do you think you're making?
Oh, I think a micron.
Thin.
Yes, it's very thin. I think it's just enough to attach the nanolayer.
And it holds up to the plasma?
And to the plasma.
To the stainless steel.
To the
Yeah,
stainless
I
steel,
mean-
yes.
It won't
Yes.
flake off?
No, you may scratch, don't go off.
So Dave, you
Very,
have to
very-
understand that if you leave it a long time, the thickness will go up. So it all depends on the time you leave it in the electrolysis.
Nice work. Anyway, Gert, you need to think about some kind of blades inside the sphere so that you create a turbulence.
But that will appear if you glue some skirts, as you have seen in the previous picture. That skirts will create the turbulence needed.
Okay. The blade, does it have to spin separate from the spinning?
Don't put the blades. If you put a skirt, it's enough.
Okay.
Just small. You just need small
Turbulence.
small turbulence. Yeah, you don't need some big blades or something.
You don't need to make a mixture of all the gases and plasma that will appear. Otherwise, your plasma would be disturbed.
Okay.
You need a small turbulence at the surface. So the skirt you'll be gluing. Be careful not to have glue appearing. Glue must not be seen from the inside.
Okay.
Because glue is matter, and you have to have the nanomaterial. You need the nanomaterial be the only part seen by the plasma inside the reactor.
Yeah. Now, what kind of glue you use? Normally, I use epoxies or something.
Well, it's perfect. It's epoxy also that has been used. Yeah, there are different epoxy. The epoxy for plastic. There's epoxy for metals. In this case, you would use an epoxy for metal. But if you have to glue, well, as was done previously on the plastic sphere, you make a mix of the two epoxy, so it will glue on the one side on plastic and on the other side to the metal. So that's for those who want to make plastic reactors. Gluing that with a mixture of two epoxy, same quantity of each, will allow to have a very good glue to glue on the one side to plastic and the other side to metal.
Okay. Thank you.
So, other questions?
So if that's the case, then you should be able to use, excuse me, aluminum spheres to have them coated directly, and as long as you have something in there to create the turbulence, then aluminum should be able to be used as well. Then
I would say yes and no. I explain. Making some electrolysis of your sphere would allow you to have some copper on the inside. Don't forget that aluminium has always a thin layer of oxide, which would be something that will not allow a nice coating with copper. So it should be first taken away. But the problem is elsewhere. When you want to coat the aluminium with that thin layer of copper, if you reach to do it, would have another problem, which is that the aluminium in caustic will be completely dissolved.
What about the idea of using the aluminum as a substrate and creating aluminum oxide rather than copper oxide as the catalytic layer, as the nano layer?
We've done this and is as effective as copper oxide. If you look at the Fukushima video, you see like a radiator on the table. That radiator is aluminum oxide nanoplating. So the problem with aluminum is that it evaporates very fast. So you have to use a thick, what do you call it, very thick aluminum layer. As I said, you have to understand how aluminum is. When you open your plastic to use the copper, it has an aluminum compound layer as well, same like the same length sheet. If you put that in the caustic history, you find that it literally falls away and disappears. You can use aluminum cores that are much easier and lighter to use for higher speed. But you have to use a good thickness, and the layering it can be used. Aluminum oxide nanolayers are much better in some cases for the core. This is something I said before. Do not change everything to copper. Try different materials and find a way how you can create nanomaterials of them. Because this way, all the reactors will be behaving in the same way. We will not learn anymore. If you have a stainless steel, like the way Morocco is doing, we are looking at every aspect to see how we can create nano layers from stainless steel 3 or 4. This move or this consideration to change everything to copper will not teach us much more than what we know. The way John is doing his reactor with ceramic will find a new dimension. So it's very nice what Gerd has done with his reactor, but try to find a solution with the material you have. It's not just copper which can be used. You can use aluminum, you can use chrome, titanium can be used. We have nano-coated gold. If we have a millionaire between us who likes to make a reactor out of gold, you can now quote it by itself. It's in the pictures of the foundation we showed years ago. So don't try just to use copper, then we don't have any quantum knowledge and we don't see the beauty of the creation and the dimensions. If you have aluminum, try aluminum, go and study why it is oxidized and how you can separate and do it. We just realized with Marco that we were looking to put a copper on a steel, stainless steel, and copper actually makes the steel rust-proof. So that is something we didn't know. We just now we know what we're going to keep away from. But don't try to make everything all from copper. Then we actually become like monkeys see monkey do. And this is not
right, Mr. Keshe. And in that case, my first attempt at nano coating was with two different materials, with stainless steel and with aluminum. And I did get some interesting results off my aluminum. I'm going to take a picture of it and I'll just put it on the Skype and you can see the kind of what my first attempt was. Yeah.
Yeah, but what we did with Marco this week in the lab was that we added, we added the top of the aluminum foil, like a coating foil, aluminum to use the coating, and we added pieces of the nail of the Coca-Cola bottle. So to see if we can create a condition for it, or that we can allow stainless steel to be allow itself to create its own nano layers. We were just reading, that's why there was a voice in the background at the beginning. Mark and I were looking at the condition, maybe we can use sulfuric acid to use the chrome in the steel, the stainless steel, because it's a high percentage of chrome, and we can use the chrome to go as a nano layer. So look at different options. Look at the weakness of the material you're using and use that weakness to create your nano layers. So in the case of stencil 304, it says it's about 18 to 20% of it. So we are using that weakness to see if we can make a chrome oxide on the top layer of the, what do you call it, of the steel. And I can do the sulfuric acid. What we really just done. So we have a material, we're going to test it. Once we find a solution to stainless steel, we'll put it out. But what we got, we know the results most probably today. But what Keshe has done is beautiful, it's very nice. But what is the thickness of your layer?
It was just my first attempt at coating, and what I actually used was the Drano kitchen crystals, which has the sodium hydroxide in it, but it also has pieces of aluminum. And what I find is that these pieces of aluminum, they of course put off heat and they turn dark right away. But on the aluminum sphere, which is I think 2 millimeters thick, it has a different kind of coating off of it, and of course I've been able to get voltage off that as well, different parts of the sphere. But you'll notice that it's not a uniform coating. It has stripes on it and stuff, and it was just my first attempt to try it, and I think I got pretty good results off of that one.
There's something which I explained before is part of the thing you've got to learn, is when you put your material in any chemical combination, when you take it out of the liquid and you place it on a metal mesh to keep the conductivity within the plasma, you close the cap and you leave it for 24 hours and you repeat the same process. When after 2-3 times you've done the process, You just don't take your system out of the box and try to work with it. You create different oxidization. The drying process is too fast. What you have to do, you just move after when you decide that the layering is exactly what you want, you move the cap of where your reactor core is just a little bit open. You just create a minute circulation and you let your system dry over 1 or 2 days. Because if you just take the core out, especially with copper, you create different kind of oxides. In a way it's good, but in a way it's not good. So if you want to keep your copper layering in a very nice homogeneous nano layer, so you don't take your reactor straight away out. No, you should not allow at any point the layer to go dry, because the minute it's dry, then it allows the moisture to go into the holes of the nano layers and create rust on the naked surface deep in just between the copper and the nano layer, and then it starts bleeding, and that's where you get blue or green colors. So when you finish your thing, you have enough thickness with your core, you open a very, very minute gap in the skin. You put it in a dry environment, or you empty the water from the bottom of your tank, which you said you got to put, and you allow very slow drying process. 1 day, 2 days is perfect. Otherwise, you create oxidization you don't need. This is a tip I give you, because then you see your core is homogeneously black, and it's a perfect nano layer dust. You see this with the reactor generator which we have. It took 2 months to do it for me, but I have a perfect black homogeneous nano layer. In the cores which we used copper sheets from the from the mobile phones, you see the mixture because they were dry too fast. That was set up deliberately for that process. But if you do it very slowly, you'll find a total black sheet, and I have that up on it.
Right. And I've kept it in a sealed container with a little bit of water in it, so it'll never dry.
Don't use water. Use the liquid from your caustic. The caustic you use to heat it up. Put just a little bit at the bottom of your container where you're drying it. You make the electric connection 2 or 3 times to make the wiring connect with all the layers. Then you can repeat the process, but when you don't, it's enough. You see it. It's with the eye, it becomes like a velvet. You see the velvetness of the layer, and it's all black. And then you move.
And actually, on that note, I have another picture that shows with the second. This is, I think, my 3rd coating, but with the second time on this on these materials. I'll send that as well. Sorry to interrupt you.
Don't worry, but to take your time. The processing of coating of your core, what you've got there, it should take between a week to 2 weeks. And then you see the reward of your patience when you run the reactor for energy or lift. Your plasma is more homogeneous. You don't get wobbling in your plasma because different nano layers, oxides, create and attract different magnetic gravitational fields. If you're looking for a homogeneous plasma, you need to produce that kind of thing. These plastic cores you see when the reactor is getting tested, the purpose was to create a mixture plasma. And the process is very, very, very easy. But take your time. Take your time as long as you can. Never in the process turn your core upside down. Keep your core all the time facing down. Look up into it, then turning it and look into it. Because what you do, if there is any residue of caustic will block the holes. You don't see it, but in the process when you started it, it's all gone to the edge. There's no problem. But if you turn your core upside down to look at it, and then you create impurities in your layering.
Must it be heat resistant? The core?
Pardon?
The core and plastic has it to be heat resistant or not?
No. You don't generate any heat in your plasma.
Okay.
You do not generate. This is what is called. I was with a bunch of nuclear physicists yesterday, and they said this is a cold fusion. I said cold fusion doesn't exist. Plasma works in natural environment, so which is ambient temperature.
Yeah, it's because you said last workshops that you used glue with heat resistance. That's why I asked.
Glue should be heat resistant when you are gluing the small sheets to your core, because when you put it into the caustic, you have very high temperature there, and if the glue is not high temperature resistant, you will find out that the sheets will fall out from the core.
So I would add this fact. Once you have glued your sheets with the nanomaterial coated, you once again go into the caustic to have the nanomaterial build another layer on the material. So when your spheres are made with those sheets, you grow one layer more of nanomaterial. That's why the glue has to be heat resistant.
Okay, the finishing layer.
There's something which we know here. I've done it. This is very effective. To get a very nice homogeneous layer, when you finish, you want the last coating. Do not submerge your core in the caustic liquid. Create like a plate where your material stays in like a sauna bath of the caustic. You understand? You don't put steam bath. Yeah, you make a steam bath of caustic than actually the liquid of the caustic. With this process, when you put boiling water into your container, after the boiling is finished, you put your container, reactor on the plate and you close it. Because that initial jumping off of the water with the caustic and the high temperature releases like a caustic powder. You avoid that to block your nano coating. So you put the water in, you boil it. When the boiling is finished, immediately you put your container in. The heat is enough to start the process, but you don't damage your or you get a very nice clean surface.
So just for the first nano layer, just submerge, and the other ones.
Even the first 2 times. I sometimes do 3, 4, or 5 times. Whatever. When you decide it is good enough, just to finish it off. But please make sure you don't touch with your fingers. Yeah, and you have to work in a very fat-free environment.
Yes. Thank you.
Eric,
asked what should be used to wash the copper foil. The best way is water. And washing soap, detergent will add for washing the copper foil.
You wouldn't use like vinegar or acetic acid, which is known to make copper very shiny and give it a clean surface to start with, or no? Is that not been considered?
It's not necessary. Just to take away chemical products that are that make the battery.
They would be water soluble, you mean?
So just use water and soap, and you'll see nothing like that.
I think there was another question regarding, is it safe or difficult to open the batteries to start with? And is that an issue as far as, I haven't opened one before, and if folks do try to do that, is there any issues involved there? I'm assuming you should use a discharge battery probably before you start, and gloves, he mentions. They'll be
What we have done, one of the batteries might have been charged when we opened it, but the material that was put apart, which is the aluminium and the chemical compound, they have started to smoke. So if the battery is loaded, it might happen. So be careful for eventually fire.
Thank you for that word.
Just add the product in water, so it will calm the reaction.
Use your common sense.
Well, I was saying that common sense isn't, so that's why I mentioned that for other people as well. So.
There's a question after the water after washing the copper is harmful for the environment. Should we take special precautions in that? And the smell is very intense. Is it harmful?
The smell, it would be preferable to have the ventilation sufficient not to inhale too much of that smoke, or preferably not at all. So the harmfulness, I couldn't answer, but any smell like that should be avoided. The smoke, we didn't have any fire, but it was starting to smoke quite a lot. There was a reaction happening. So I cannot say we didn't have any fire, but we put immediately water with it that has been stopped at that moment. I don't know what would have happened if we did let it go.
If normal copper sheets are available, can we just use that instead of getting it from a used battery?
You use whatever you find. If you have an easy way to have foils, of copper foils, do so. That's what was said, that in Africa they have a lot of old cell phones, and batteries would be easy to find. In a country where you have some distribution of foils of copper, use them. But for the most of the people in the world, they might more easily have an old battery, a cell phone battery, then well, in the Western countries where you can easily buy foils of copper. Another question?
Sure, just to elaborate on that, is it a specific type of battery for the people that we're going to ask? Is it a nickel cadmium or a lithium ion?
Well, not specifically.
Types of batteries.
It's not specifically. Well, it's mostly the compound, the chemical compound that will vary. Anyway, you have foils because it needs a big surface. That's why the foils are rolled to make a very flat battery, but in fact it's rolled over and over to have a big surface.
Right, and I think that's why the like a AA battery couldn't be used because they don't use copper in that battery to roll it, right?
AA or AAA batteries, they are in fact not made of rolling of foils.
And you can find
right, exactly. I'm just trying to elaborate for people that will ask.
You can use any color. You can make it thin as a foil. And you can nano-coat if you want.
Let me add something to people who live in the third world nations. If you have access to toilet cisterns where you flush water, the very old ones, just get into it and you find there are copper balls in there, which is used for buoyancy to stop the water coming into the tank. We found those as one of the best reactors. In the West, they don't make it anymore because it's too expensive. Everything has gone to plastic. But if you can get your hand on old water cisterns for toilets, you have a perfect copper coil. You can use it for a single core combination. I have used it. It's fantastic for the work. And you get a very nice, system. But you can still buy it in some shops, but it's a special order. So if you can't get hold of these things, go into the systems of the old toilets and look in there. You react inside.
Are you talking about the float, Mr. Keshe?
Yeah, that's it. Yeah. Because it's already has a hole.
You just drill a hole?
That's genius.
You drill a hole, you put caustic inside, you make your coating internally. Finished. But this is also way, but that is good for a single core, and they are very, very thick. They have enough thickness to stand the vacuum. But the only problem is you have to centralize it. You need to put a pin outside in your reactor that you keep at the centrifuge high speed. It doesn't fall out of your core. And you can work with those that are efficient. This technology can be used in any shape or form.
That's genius.
It's not. It's just thinking simple.
That's
always low.
Genius.
The thing is, the way I work is to look what is available to majority of the world population. The simplest way at no cost. And there are different things available that you can use, but this is one of the easiest way. You have a core in your hand. You get a core cut, it costs you €2,000-3,000. You can buy it for $1 or $2 or an old system. Just tell your wife the system doesn't work, I have to change it.
Yeah, good luck with that.
So that brings up the other question, Mr. Keshe, is with the vacuum. They were talking about having to bring down the vacuum inside the core. And I believe we were talking before about the vacuum inside the nano layers as what's the most important. Is that right?
Well, the vacuum inside the nano layers is a condition that is used to the opening of the plasma from the hydrogen we put in the reactor. So that's the understanding of what's happening in the nano layers once we start to spin the reactor will be, for one part, the centrifuge, but in another way you have in fact the process happening in the nano layer itself, where you'll have some hydrogen that will start releasing their electron, allowing that the nanomaterial, because they are pressed, they are stressed, will happen to react as a piezo system, a piezoelectric. Instead of having electricity built up, you have release of EUV. And that EUV will go into the center of the whole reactor, helping the ionization of the hydrogen inside the reactor. So you start a reaction process that will allow the full ionization of the hydrogen inside the reactor. And that's what the first step is, to go to the plasma.
Right, so do we have to vacuum all, as much as we can, down inside the cores, or could we just flush the reactor with hydrogen and just vacuum out what we can with a cheap vacuum pump?
We have to go down in pressure because that allows that opening of the plasma. If you don't vacuum, keeping the high pressure, all the atoms of hydrogen will be pressured together, not allowing that ionization. So the lowering of the pressure is an important step in the process.
Let me explain what this is a misunderstanding. There is a misunderstanding in this process with us, and that is the reason we produce high vacuum or try to create a high vacuum, and the best vacuum we can do is to accommodate the freedom for the rotation and movement of the plasma. That's the only reason. The higher vacuum you create in your chamber, the more room your plasma has to expand. It's like you're putting 200 people in a room and you say, now dance. They cannot move much. When you put 100 out, the other 100 can move a little bit more. And if you just want to leave one or two, they have the whole dance floor. This is exactly what you do. So the vacuum condition is not to have a high vacuum, it gives you this and that. It's trying to create a condition that your plasma has as much room itself to open up, that first of all, maybe you left it one or two atoms or molecules, and then you can literally strip it up and open the plasma. So how you create this, how you empty the room from the dancer by kicking them out or you're pulling them out, is all the same. At the end, you try to keep one or two dancers on the floor. This is how you got to look at it. A lot of people say we need a high vacuum. Even in the universe, the high vacuum condition, it means this one plasma can cover a large span of the universe. That's all it is. It's not the number of the plasmas, because when you have one plasma, communication is easier because it's internal. This is what we call universal communication system. 0.0 delay time, because you break into one plasma or as few as plasma as possible. And this is what is called vacuum. You got to change your mentality and understanding of vacuum. You try to leave as little dancers and as few dancers as possible on the floor to dance and play. Then it's easier for you to play with all the plasmas and bring them together. And this is the definition of vacuum to me. Not trying to become as high as you can. All the vacuum is when you put your hydrogen molecules in, or hydrogen atoms from the Coca-Cola bottle, it's not a crowd of them. It's a few of them. You can even do 2 or 3 times hydrogen atoms evacuation and do it again, because when you do a vacuum, if you do a vacuum and just pull it out after 1 minute, you still got thousands of molecules and atoms still in the core. What you do for a high performance, you leave your core maybe for half an hour, that the suction will get hold of as whatever is available, plus what is the deoxidization of the surface. You empty a chamber and you think, okay, I've got vacuum. But what you forget is the top layer of your material in your chamber now has a freedom to move. So it releases what's on top of it. So when you create vacuum for your reactors to start testing even before you put hydrogen, you vacuum, you stay for half an hour, and now you leave your vacuum pump to your tank open, that it can grab as much as it can. Unless you have a super tank, what they call ratio of your reserve tank to your core in the ratio of 100 to 1, then you can do it in 2 or 3 minutes. But still with that, as we say, you try to grab whatever molecules are in the core out, you lock your core, then half an hour, 10 minutes later, you open the core and you vacuum it again, because if there is any molecular or atomic release from the surface, you extract out, because then your core will not be pure. And then you put the hydrogen in and you extract again. You do it for a second time, you extract again, because if there is any gap or any weakness, it's just like when you paint a wall. You scrape the wall off any loose paints. This is the same process. You have to take all the loose molecules on the surface out, anything which is not there out, and then you soak it and you wait to see if there is any more which is coming out before you start painting. It's the same process. So you have to allow, if you try to do make a core and test it today and vacuum it today, good luck to you. You have you become better than God. God takes billions of years to make a solar system. If you want to do it in half a day, you must be a genius. So do it, understand the process. The vacuum, you can create vacuum in your reactor by heating it up externally, use a microwave, whatever you do, try to open a space. That's all it is. Make a space that your plasma can play. And when it can play, it literally, like the same dancer, it touches the walls. You know, if it dances too fast, loses control, it touches the wall. And that touching of the wall is the energy you need. Because when you hit the wall, you release energy. And then that's where you break into your plasma. That's why the nano coating is like a cushion, but a cushion that can absorb and open up the plasma. Now we start explaining the process. You have to understand exactly why you're doing things, not do it blindly. You can create vacuum chemically, you can create vacuum with the magnets, combination of rotating magnets is done. This is how the universe does. There is no vacuum pump in the universe. Vacuum is what we call not availability of atoms in the environment, or as few as possible. So,
sorry, Mr. Keshe, you broke up for the last couple of sentences. We weren't able to give
condition. Yeah, the vacuum condition is to make as little as possible elements available. So, elements in the universe are made of magnetic field, gravitational magnetic field. So, you can use a beautiful high vacuum by just using magnets or magnetic environment. You don't need high pressure pumps. You don't need high as I said, in the universe there is no vacuum pump. And if you can use a single atom, a single molecule, single plasma, then you understand the next step of the development of technology, which is a zero-time communication. And the Brazilian scientists have already achieved that. They understood that part. They have a zero communication systems which are testing. So in your reactor, you try to create an environment with as little as possible atoms or molecules. And what you do, molecules are heavier, atoms are much lighter. So when you use your Coca-Cola bottle to create atomic hydrogen, to release atomic hydrogen, you, because of their activeness, you kick out the molecules of hydrogen in your system. And this is how you look at it. You create a magnet around the system. With magnetic fields, you can create a huge, powerful vacuum condition. You don't need high pressure. But you have to understand how to produce it. In the future, I'll show you how to make high magnetic vacuums. And it costs maybe about less than $50. There is a specific magnets you have to use in a specific formation. And all you do, you play football. It's like if you play squash, you hit it so hard enough that it bounces off the center. Or you hit it hard enough that it gets absorbed by the construction, by a structure. So now you understand the definition of vacuum. You don't need a high pressure pumps or high vacuum pumps. You understand?
What vacuum should we be looking for? Are we still at -14?
Oh, you're very lucky if you get to -14.
What do you recommend?
The best I've achieved is about 12, 13. And
12,
that's
13.
using even by 9 or 10, you're above atmospheric, space vacuum condition. When you go to -12 or 13 or whatever, it means there are less molecules in the environment of the core. But when you get to that level, if you don't have nanomaterials and you have like different normal metal, they at high condition they become like evaporating. And their molecules and atoms becomes part of your reactor core material. You have to understand the process and then follow the process.
Sure, it frees up the electrons and the centrifugal forces them into the lattice.
Yeah, so they become part of the material in your core.
Oh yeah,
that's why we produce nanomaterials trying to be homogeneous, and we try to keep it at a given level. There is a reason for all these processes, not just to create a condition. Is to create an environment that the process of opening the plasma can be created. And you do this
Yes, I have a very punctual question for you because you are at this stage. Supposingly that you are vacuuming the core as you explained, and you do not rotate at all the core. So is my understanding that because of the coating that we have on the inner side of the core, the atomic hydrogen, atoms of hydrogen, they are elongated by themselves. So as in the first stage...
They don't elongate. They open up. If they elongate, you can create turbulence. There is certain amount of turbulence even in the non-rotating reactor. But centrifuge and magnetic plasma flow creates that turbulence. This is how initially, like stars create their initial movement. Their interaction of the molecules or plasma inside with the environment because the plasma is not the same strength. So as they lock to the other fields outside, they try to catch up, what you call elongated. They don't become, they catch up, touch, and they create a speed. It's literally the rotation comes in respect to the environmental magnetic fields available. And if the magnetic field environment is very high compared to the plasma inside, then you will see that the star will rotate in a clockwise. The rotation speed of a star in the universe is dictated by its own gravitational magnetic field inside, the strength, and the environment and other stars' strength near to it. If the other stars are high powerful magnetic field producers, they, in the specific conditions, will rotate the star clockwise. So if you can do the same thing with your plasma, you can turn the plasma clockwise and anti-clockwise, then you start your rotation, your cell dynamic. But that knowledge in about a few weeks will release, because at the moment you have to understand the concept and the technology. You can create a very...
Yes, I understand. So in the moment in which you put hydrogen in...
Hello? Hello? I think his microphone got too excited.
Okay. Now it's good. Okay. So
yeah,
if I understand correctly, in the moment in which you put the hydrogen in, the rotation movement starts because of the fact that the magnetical condition is much stronger than the hydrogen atom strength.
I'll go back to it. The minute you introduce the hydrogen, your hydrogen atom or molecules are not the only element in that core. There are still other atoms. There is nowhere in the universe which is void of plasma. Doesn't matter how much you suck it out. So all you do, you try to put a lighter energetic for the heaviest or lazier to move, to kick them out or put them to the side. And as John was explaining earlier, if you can reach that point, when you put a hydrogen in, your hydrogen doesn't go to the center of the core. Your hydrogen goes to the edges of the nanomaterial layers. By centrifuge and by vacuum condition, the lighter goes in the center, the heavier goes outside. If you have created a plasma in your reactor, so now the center of your reactor is a plasma. So the next heavy one is a hydrogen. And that hydrogen between your plasma and your nano layers become the feeder of your plasma. Because as the plasma rotates, you ionize with the extreme ultraviolet your electrons, or you can capture some of the electrons in the cavities of the layer. So the new plasma you created automatically becomes the feed for your plasma. This is how solar systems work. This is how we see a long life generation in the universe. It's not that energy comes from somewhere else. It's the conservation and reusing of the same material. So as your plasma weakens on the boundary near the hydrogen, it gets absorbed partially by the hydrogen itself and by the layers, and in the long run, it gets fed back into the plasma as a new layer. So if you understand the process, your hydrogen doesn't go in the center to become the food or the supplier of new plasma. It goes beyond the plasma, between the plasma and your nano layer, and that dynamism, as it gets stripped, becomes from molecule to atom to a plasma. Then that plasma matches with the plasma in the center, so it becomes a supplier. That's how, with a very little material, you can run these reactors for years, centuries, millions of years. Stars live. The solar system, the sun, doesn't lose all its plasma to outside. As the energy of its strength finishes on the boundary of it, they become weaker. They get absorbed back by the stronger magnetic field, which is the sun itself, when they converge into a GANs. As long as they are magnetic fields, they move away. But when they reduce in strength that they become matter or gas, then they have a gravitational magnetic field. Then they have to react as a normal system in respect of the gravitational magnetic field, which is the sun. So, like a rain, the cloud goes up and it rains back down on Earth because of the gravitational magnetic pull of the Earth. The same process happens in the universe. So, this is what we said, and it's in the new book coming out for whenever it finishes. I always say that the planet Earth started life at the boundary of this solar system. And as gravitational magnetic field of the sun is stronger, we are getting pulled in. And then in a few million years, we become part of the sun again, and we evaporate, and we go out as a magnetic field. That's why we are not here forever. But the conservation of energy, conservation of magnetic field, gravitational field, enforces this position. The same thing is with your reactors. So your hydrogen doesn't sit in the center. Your hydrogen sits outside your plasma, between your plasma and the nano layer, or nitrogen gas or argon gas. And as they ionize, the plasma becomes equal and it goes back to the center. So you feed your plasma continuously with the gases you put in there. Can you understand?
Yes, thank you so much.
Pardon?
Is the sp2 like the Oort clouds?
Very much so. That is the point. Because it's not like it is. No, it is. Because if you look at the only indication, the full indication we have that the Oort clouds are nano layers is that these clouds get absorbed by the outer layers of Saturn and Jupiter. And if you look at the poles of the Saturn, we see the hexagonal clouds. I've said this before. The hexagonal clouds in the north pole of the Saturn is only due to the SP characteristics of the material which is there. In electronics, in high definition, high power semiconductors, when you put 3 layers or 2 different layers, but 2 different materials, but in 3 layers, automatically we see hexagonal shape pattern. And the north pole of the Saturn, the hexagonal clouds, in Jupiter, partially we don't see it, but if you look further out, you see it, confirms the existence of nanomaterials in the Oort clouds, because they come back and get absorbed on the outer layers. And these layers indicate the conformation of the nano GANs material in the boundaries of the what do you call it, this solar system. The same thing happens with your reactors. If you build your reactor in a specific condition, you will see the ring of Saturns on it, because your reactor is gaseous. It's not a solid reactor. If you use a single core reactor, you will see the ring of Saturns in much weaker point. But if you use a multi-core, you will see 100%. I've seen it. You will see it. You will see the ring of Saturn. Depends how many gas layers you use in your reactor. The ring of Saturns are created because of the layers of gases in the outer boundary with a solid core in the center. This is very much like Pluto coming in. Pluto becomes the center, is a solid material, and as it absorbs more layers of gases, each gas creates different magnetic gravitational field. The thickness of the ring of Saturn we see, a few kilometers, this shows the size of the solid core in the center, the mother. So, and then what you see as what they call it, the black rings, this shows the separation layer between each layer of the gases which is built the material, the gases. This is a characteristic of the gaseous planet. When you use different gases in the layers of your reactor, and you have a double core or you have a solid core condition in the center, you will see the ring of Saturn. It's a natural process. Where the darkness is, what we call the dark rings, separation rings, these rings are created because there is a balanced condition between the environment of the two layers in the gravitational magnetic field. There is no reaction, there is no magnetic field interaction, so you see it as black. And then if you look at the layers, the size of the ice cubes, ice molecules in different layer changes by the nearness to the center, to the ring, to the actual outer boundaries of the Saturn itself. That shows different gravitational magnetic field hold on to different size of material. We don't see so much of the little one where the big ones are. This is how it happens. It's very much like you get a hailstone, a very small one or a very big one, depending how many times it's rotated and the condition of environment. The same thing happens. We see specific size ice, what do you call it, blocks in different rings. It's just because that ring creates a gravitational magnetic field which holds that size magnetic gravitational guns in that ring. These all I have explained in the book which is coming out, in the book number 4. So, and the paper called The Ring of Saturn is on the back of the books. If you read the books, we always said, in this paper I have explained all these things, and Dirk has made a beautiful drawing for it a few years ago. So, in your system, if you use multi-core, you will see it. If you use a single core, but multi-layers, then you see different things. But if you use the multi-solid core and multi-gas layering, then you will see the ring of Saturn in every reactor you use. And then you can use this principle for defense technology of your space reactor. You don't need to you create a multi-layers, and that multi-layers, you can even dictate 1 or 2 rotating in different directions by choice of the material or the plasma strength. Then you create your magnetic shield around your reactor and on your spaceship. These are advanced technology, and in the future, as you learn more, I teach you how to do it.
Will the rings be formed outside the reactor or inside?
Outside. You see it. You don't see the ring of Saturn inside the Saturn, huh? You see the ring of Saturn outside the Saturn. This ring production is a highly advanced defense technology. This is what we say the time of war is finished. Whatever you make, we can make a magnetic field of that layer in one of the layers. So whatever bullet, intercontinental missiles, you can make that layer to match that. So it makes it totally obsolete. This is why we start opening the technology this way. All this making the latest weapons with phosphor, with sulfur, with whatever, with what do you call it, hydrogen bomb. This is all finished because now you understand how
we just hold
one
it
of
at
the
a direction.
certain directions.
Yeah.
Certain strength and certain direction. So you, as we say, you run out of fuel. In a way, what you do, you match the system runs out of fuel. If let's say you have an intercontinental missile hydrogen bomb, you just make a hydrogen level in your reactor. The bomb will go, but there is no hydrogen to release because it's already changed. You can change it to very much like a carbon to a diamond. A bullet is a bullet as long as there is a carbon inside the mixture of the powder. When you change it to a diamond, in a very simple process, the way we do with MS, it never explodes, huh? So the bullets become what I call beautiful rings on the finger of women because it's a pure diamond in it. You just need to open it. This is the reality of this technology, and this is what now we opened it so openly. The point of destination, you have shown it to the knowledge seekers. We just need to put certain reactors in certain position. In that environment, you can create whatever material you need. Ring of Saturns you will see in your reactors, especially if you have a multi-core. and you empty the center from plasma. We done it here. I show the knowledge seekers how to do it. When you empty the center core totally, and then you start multi-layering your outer core, you automatically see the ring of Saturns around your system. And the size of the ring, the thickness of the ring, is equal to the diameter of the inner core, because it's solid. So the mystery about the ring of Saturn and all the rubbish we hear by scientific world is meaningless, because you can make a reactor and you explain it yourself. And how much you create vacuum in the layers, or what layers pressure you put in, but then you get different strength rings. This is something which you can test it yourself. When you create a vacuum, total near enough vacuum, and then you can put the hydrogen at 1 bar, you put nitrogen at 2 bar, or you put your argon at 3 bar pressure into the core, you will find out that the only thing will change is the pressure on the layer next to it according to its atomic weight. The argon will not go into the position of the plasma, but because of its pressure, will increase the pressure on, let's say, nitrogen, and that allows the release of much faster of extreme ultraviolet. You got to understand, put the picture together. You have all the pieces of jigsaw. Now you have to put it in to see the beautiful picture. We explain most of this in all the teachings. So your core, your vacuum is trying to get as little as other things inside, that you can have a homogeneous plasma or material. And how you process, you build your reactor. That's what I said. From the time you cut your core, you pray for it. The way every time you make the layer, you pray for it, because this is what is going to give you life. And you give life to a child, and you pray for his child, or your mother who gave life to you. The same thing happens with this. From the time you start the reactor, you give part of your soul to it, and then you find out, if you have a devilish soul, you get a devilish reactor. If you have a beautiful soft soul, you get beautiful reactors to work with. Because this is part of the structure, and this is what you got to realize. Any other question?
Yeah, if you're doing a dual core, or say if you're building for lift, do you have to nano coat the interior of the outer sphere?
Of course, yeah. I think the one Armin is using at the moment, Armin core is the outside core in America. Yeah, Armin is using the outside core of the system which we brought from Iran, and Marek is doing the inner core. Armin is just coating the inside of the outer core, and Marek is doing the inside of the small core and the outside.
And does the outside of the inner core need to be nano-coated?
Yeah, you get the response.
Uh-oh.
You have the first picture that was there, you actually reverse picture with small blue ball, small reactor plus in a core. It's coated plus from outside.
Your transmission's breaking up.
In the first picture with blue ball,
yeah,
is the inner core of the system, coated from outside and also from inside.
Okay, inside and out on the inner core and the interior of the outer core.
Yeah.
Thank you. Eric is asking, when will we see a video of these reactors operating?
When we'll have them working.
We have to get please be patient. We are here 2 weeks, 3 weeks, and don't expect in 2 or 3 weeks from us that we will have a working reactor. So the preparation takes some time.
Let me explain something if I can jump in? Very soon we will release once the manufacturer gives us the generator, we will post the drawings of it and then the actual pre-production unit. Later as with next 2 to 3 weeks we should expect it.
Excellent.
So what happened, we would have shown the system would have been produced, but because of the technical advancement in technology, the manufacturers with us became with a new design, so we reduced the shape of the reactor, the structure of the reactor. So they went back to the, drawing board to make the system to be more efficient and can last a longer lifetime. So the new, energy reactor should be, the pre-production should be with us within the next 2, 3, 4 weeks, I hope, because the designer has gone to China, he's back yesterday, and they are bringing in new materials. The point I go back on is that we have given the power generator as a gift to the Italian nation. So the product.
You're breaking up, sir.
Production, the design is out.
We have to understand one thing.
You're breaking up.
Yep, we seem to be losing part of the transmission at this point in time.
Like every single time he says something significant.
Yeah, it's a little. Could you try it again?
Can you hear us? We lost on one computer, we came on the other one.
Yep, it's clear now.
Yes, just Arnold open another laptop and we all got kicked off the original. Now we're on Arnold's laptop.
Okay, you broke up right when you said you gifted the reactors to the Italian government.
Yeah, we haven't given it to the government, we've given it to the Italian nation.
Okay.
So the Italian engineers and the company who are developing it and go into the manufacturing phase, now they are doing their version of how they see it to be more efficient. For example, you have the feeding lines at the moment where we feed gases through different pipes. Now, I think I explained this before, the engineers and the designers, they see this as an additional problem. So what they're using the central, the central bar of the generator, of the motor, of rotating the cores as a feeding access to the core. So they are eliminating one of the problems of having different connections.
Nice.
And they are coming up with their own, their own version. I've seen it, and it looks, it'll be coming when it is 3 weeks too.
What kind of kilowatt output are you talking about here?
What would you like? You would like 1 volt or would you like a megawatt?
Megawatt would be nice. Can I get that in a month or two?
Depends what they need. I told you it's out of our hands.
I'm just kidding.
All we do from now on is consulting them in material and loading.
Yeah, I was just kidding, Mr. Keshe.
No, don't worry, I understood. But the position is that we only, from this position on, and what we ask them when they finish, they allow us to have the number of the reactors which we have, we have got reservation on.
Yeah, the guys who put the deposit on.
Deposit on, they receive it, the Italian version. And then to discuss how we do it. But from past 2-3 weeks or more, let's say a month or so, the whole production and the design of the energy version is out of the hand of the foundation. It's in the hand of the Italian engineers and the company which is going to produce it. It's not with us anyway, it's with the manufacturers. And the design we gave them they see through the design and the knowledge and the materials they have, they can make it in a better way. So they have redeveloped it, and now what we are doing, because there is a possibility of like a leakage because of the different atmospheric and the inner core pressure, we come up with a new concept that we put in vacuum. So the motor heating, the vacuum leakage, and all that is eliminated in one go, which is a new development. Because now, if you look at the reactor, which we brought in from Belgium, is developed here, there's always possibility of the leakage because of the sealing, rings. Now the whole assembly will be suspended in a vacuum cylinder, like a gas cylinder. The gas tanks, you buy your 20, 30 liter gas tanks at home. It will be suspended such a thing that we eliminate any leakage problem from the cores. So the cores working. These are the developments. This is manufacturing development which is happening. So when we show you the reactor, it will be like in a gas cylinder, but we'll have two connections and one gas connection. And this is what is changed. So it's not that now it's not in our hand, but I consult with manufacturers in how the next step going to be. They are introducing new designs because they are on the edge of science. They work with the aeronautics and high performance engines, and they know new techniques which is for the aerospace. And now they are bringing that in conjunction with the reactor. But we have a condition that, as I said, all the parts of the reactors for Italian nation will be manufactured in Italy. And then a decision has been made, most probably by the people around this table, as the people who run the foundation from now on. How are we going to allow the technology, the reactors, to be cycling into the other nations? If we give the same, it will be a copy. But if we say this is the parameters, they come up with new versions. So this is the news about the power generators, where we stand at the moment today.
I heard that the man you cured of ALS is helping with the power converters.
He is a sales managing director of one of the biggest, inverters in Italy and in Europe. And he knows once he starts moving, he's doing the inverters if people want the AC inverter. This reactor always produces DC.
You've got out of the reactor always DC. So if you want to use normal house equipment, you need inverter to convert DC to AC.
Approximately how big is the new design, the new generator design?
What? How good?
I think he said how big.
How heavy?
Should weigh less than about 10 kilo.
And the size?
I told you, a 25 liter gas cylinder, that's what they're looking at.
Oh, the gas cylinder, huh?
You know the gas cylinder you go camping or you cook in the house with?
Yes.
Propane tank.
Yeah. Small, it's like, 40 centimeter diameter. Something. It's at the moment, they are deciding that it's out of my hand anymore. But the manufacturers, with the people we gave the pre-development, and part of the Italian Keshe Foundation, people who supported and did the work, they become the manufacturers and the distributors. So they consider all aspects themselves, and with collaboration with the Italian government, will be done in a way that the production does not stay in one part of the nation, because Italy is divided into the north and south, and industrial part is in the north. So there are a lot of. We try to bring every aspect. So parts can be manufactured as much in south of Italy than north of Italy, and the wealth can be spread the same way, and the job employment will be spread the same way. And this is once the prototype, the pre-production unit is complete, then most probably the Italian government will have a certain allocation, because all the units will be subject to Italian taxation and production of income for the nation. And in our recent meeting, then this is a decision of the Italian parliament, most probably, and the Italian government, how they're going to tax these new systems. It's become a collective work at the moment. It's not just Keshe Foundation anymore in Italy. This is what we tried to do in Belgium, and we got blocked because one man wanted their whole thing themselves. Now we have spread it, and the technology is in the hand of 2-3 design companies, partially space, partially motorbike, and partially automotive. The company has expertise, so it's a collaboration of different companies in Italy. And then when it's done, it's been agreed that the big gift is gift to the nation. Then they have to decide how they're going to do it.
Hello. Can we touch a minute on how what system you're using for energy extraction from the reactor?
It's the same as your a plasma.
Like a magneto-hydrodynamic?
No, the plasma releases its energy according to the power factor.
Okay.
If you go to one of the old Keshe Foundation Keshe Technology websites on the internet, and it's part of the we still have it as part of our logo in the generator. You see a sphere with a copper ring, 4 copper rings on it, with a gas on the top. That copper ring, those copper rings on the center column is from the strength from the plasma. Yeah, those are the pickups. Yes, those are pickups.
Nice.
You understand?
Nice to meet you. Oh yeah,
yes.
That's nice.
I told you everything is very easy.
Well, easy for you.
Yeah, but it's years of research. I keep on saying nowhere ever in human life such a technology is so advanced, which covers everything, has been put in the hand of public in one go.
Oh, never.
So in past 3 weeks now, the knowledge seekers here, they are working with the reactors which are built 10 years ago. I think they have told you. I put all my reactors on the table, and I said, now you choose which one you want to play with.
I hope you picked the one that was floating in midair.
Armin is working with it with that is like half and half. The only thing which we don't because it's part of keeping to what we agreed with. Even the reactor we showed in the peace conference, which is the original reactor for the energy production, is on the table. I've never seen any of them having the courage to say, I want to work with this one. The only thing excluded is the Iranian space reactor. That's not all. I mean, it's there in the lab, they can see it, but they can't play with it. But any other reactor is on the table. John is working with his ceramic. Marco is playing with his, setting it up with his stainless steel. What else we have? Jorge is playing with a very nice bunch of magnets. We don't know what he's trying to do to prove to us, but we are waiting to learn. Yukoko is still as a refugee. She's looking for a place to attach herself to.
I did use the same system of reactor, and I'm using different types of containers from that lab. And we're making the new reactor.
I was here yesterday.
I adapt. Yes, I
am. Okay. I'm going to adapt it. the whole principle we work here is that everybody has to understand. Nobody can hide. They should be able, in a space, to save their lives. They don't need to wait for somebody else. So, and the way we have set it up is it's an open lab. Everybody sees what everybody else is doing. And they sometimes give their piece of advice how to do things. So at the same time, not only we work on the energy or on the lead, we are running the batteries, the coating is running in one part, we are setting the CO2 conversion units in another part with a bunch of broken Coca-Cola bottles, half cut. And in the next few weeks, we start the seed project using the material from CO2. Everything is done together. And then next couple of weeks, we'll have a couple of medical people here and back on the team. Then we start the health section.
Excellent. Have you used like a single, I heard you're using a single or a double core in the middle and then single cores spaced 120 degrees apart within the magnetic field for materials?
Let us walk first.
Why? Okay. All right. We'll save that for next workshop.
Well, anyway, the decision has been made to make that. There are two double core because what Carmen and Marek, as well as the UK co, they'll be doing double core because the two pieces were apart and they'll be bringing them together. And as I am working on my ceramics, I'll be using an inner core also. So I'll still have quite a lot of questions to be answered in the way I'll be coating the inside. I don't know yet, but lots of experiments to make. Marek, Marco is using a static external core with rotating inside.
With rotating propeller inside.
Rotating propeller inside.
But I still have problems with leaking, so I have to seal the sphere completely. And 2 days ago, I couldn't do this.
Today is the next day.
So we have to do more testing and try to get different options for sealing of the sphere, and to seal completely, to have complete vacuum in the sphere is not such an easy job.
Is that with a ceramic core?
No, this is for stainless steel.
Oh, with stainless steel?
Yes.
Mine is fine. I use 2 double lip seals back to back from Garlock. And between these seals, I put some vacuum grease, and it looks fine.
Yeah, I have an idea for John. John, why you don't try to take your reactors to a company which is producing printed circuit boards? Most likely they are going to be able to create a copper covering of your ceramic, because they easy cover fiberglass, and there are special, sorry about that, and they have a special liquids which are able to create copper beginning of pretty much any material, and after that they can add copper to it. So that's another idea. Try a PCB company which can do that for you.
Yes, doesn't bother me at that level, if I can say it like that. In fact, I can make some vaporization of copper. Doing so, it would still be in the copper nano coating. So what's the most difficult for me would be to have coating inside the inner core. That will be the most difficult. The outer core or the outside of the inner core will be easy to make. So still have to think out the way I'll make it in the inner core because the holes to reach the inner core are quite small. So I suppose I'll have to put some, first of all, make a vaporization inside and then afterwards make the coating. If I stay with that idea, I'll still be working with copper. And as you just heard about it, working with copper doesn't open to new understandings. Well, anyway, ceramic is already one difference about a reactor. I still have some work to do. The way I work on ceramic might not be the best way for serial production, but it's a way to go forward in the understanding with what can be done with ceramic. For example, what should be done by going to other kind of materials. You have quite a big series of transparent ceramics that can be from aluminium oxide, aluminium nitride, aluminium oxynitride. You have magnesium oxide. You have a whole bunch of ceramics that can be transparent. But mainly what's the most important is to have a way of working the powders so that the sintering can be done and have a precise measurement after the firing is done. Also, the firing can be done at different temperatures, and if look at aluminium oxide or nitride, they need a very, very high temperature. So that also will depend on the way to go forward. But there are many industries working with those materials, or not, maybe not as many as they are working with iron or copper, but there are quite a few industries that do exist. They have knowledge. I have not all the knowledge. I know directions. So I'll start with what I have now, and further we'll have to see how it has to be done.
Well, it sounds to me like you have way too much.
In connection with Ludmil's question, I was wondering what will be the minimum thickness of the copper layer on which to build the nanomaterial? Because usually up to like 0.5 millimeters, maybe 1 millimeter can be electrodeposited, electroplated, and this will enable to make the core, let's say, from plastics, injected plastics. So I'm just wondering, like 0.5 millimeters will be enough as copper thickness?
Already discussed that at the beginning of the workshop, Lucian.
So Dave, go on. You had a question. Hello?
So the question will be, what will be the minimum thickness of the copper?
We don't need a big thickness. We need a few microns.
Enough to restructure it to nanolayers, to few nanolayers. So a few times nano.
So we plus 1 micron, it will be enough.
Anyway, each of us should try our own experiments. So we are expecting also some feedback from you guys, and we can learn from each other. hope we will get some results from Gert and also from, let's say, from Vince and other people in the group.
Just for my excuse, I can say I load some videos on YouTube with my name, so you can take a look there. I do some experiments, at least with the material I made. There are some micro shots, there are some scope shots of the voltages and so on. So if that can be interesting for you, you can try it.
You can post the link if possible.
Yeah, I will try. It's on YouTube under my name channel. So.
Do you want to ask another question there, Ludmil? Sorry.
No, I just wanted to mention, because these videos are the same materials they are trying to make, so that could be interesting experiments for them and everything else.
Let me send you some pictures of AutoCore. I'm just gonna download it one by one, please.
Okay.
This is Deva. Yeah, I was just, Armin and John especially. Tony is in the workshop, and he came earlier to introduce himself. And so we have just now dropped in his bio into the chat. So if you guys want to know a little bit about him and the time and so on for the interview this Friday. So I just thought I'd get my little promotion 2 cents worth in here. And if anybody has any questions, just throw them over. Thank you. Because I just wanted to let everyone know in this chat that your fellow knowledge seekers are going to be making a big appearance on Wolf Spirit Radio with Tony on Friday. So come on along and support them. I guess we've got Armin, John, and Vince that are going to share their experiences. And so this is really exciting. Let's all promote the show and get it out to as many people as you can through all your forums and everything. And we'll see you there. Bye for now.
Diva, could you say the name again of the show just so that people can look it up on the net if they need to have a connection and so on?
Yes, it's a Wolf Spirit Radio, and it's at Friday at 2 p.m. So it's here in the chat.
Great. Thank you very much, Diva.
Thank you, Rick.
Diva, I am so sorry. The names you said is Armin, John, and who?
Yeah, Vince is going to come too. I think. Maybe he's changing his mind.
Okay.
Oh. Okay, well, Vince has asked me to tell everybody what their time zones are, and sorry, I can't do that. So,
no, I'm asking you to just say 2 p.m. in which time zone?
Oh, I'm sorry. 2 p.m. Pacific Standard Time this Friday. Friday, 2 p.m. Pacific Standard Time. So I think it's going to be around 10 o'clock, you guys, time 10 p.m. in Italy. Am I right?
Yes. 10 o'clock is great.
Okay, good, you guys. We look forward to it. Thank you. I won't promote any more.
We all be suited. Okay. Do we need to wear?
Oh, do you need to wear suits? No, it's actually it's radio, so you can come naked if you want.
I'm so. Oh my God.
All right. I'll come naked with the tie.
Okay.
Just don't get your microphone naked.
Okay. I'll get off here.
Well, on that note, I'm wondering if we should be phasing out of our communications on this particular round. We've got a lot of information here to already think about and to act upon. And unless we have any overwhelming questions that need to be asked, maybe we should let the knowledge seekers go, or what do people think here? We could go on longer if we really wish to.
Some of the information conveyed earlier broke up during the Skype call. So I'm wondering if it can be written down and posted as a manuscript or something on the forum. That would be great.
We'll be doing a full transcript of this audio as soon as possible. There'll be people working on it to transcribe it, yes.
Yeah, specifically I'm asking for the instruction on how to nano coat build up the nano layer on the copper and all that. Beautiful information, excellent information.
Yes, right. It will be good to get that down in black and white, as they say, transcribed. So we'll be working on that. If there's any sections that aren't clear, then we can always contact the knowledge seekers directly and get it clarified. So, yeah, that should be probably about 3 days or so.
And also the explanation on what happened inside the reactor when the hydrogen was pumped in and it goes to the edge near the nano layer and electrons are given out to produce the electricity, and at the same time the plasma is being created. I mean, all these are wonderful information. I think if we can have it transcribed, it would be great.
Sounds like you pretty much covered it right there. So that's the beauty of it.
Oh, you've been waiting for years, guys. For years.
Right.
Maybe one thing that I can add, what is going on in the reactor, we can look at like the Earth or like our solar system, which has twin star also, and every 36,000 years, the twin star came near to our solar system, and in the interaction between this twin star and our solar system, you get interaction, and because of this interaction, you get different materials that are coming towards our sun. And if some of these materials hit the Earth, let's say, they can cause disaster. Scientists now, archaeologists can find this in the different parts of different layers of the Earth, that every 36,000 years something happens.
Yeah.
And planet X, we can see the parallels inside of our reactor. We have gas state on the outer side of the reactor, and this gas state material interacts with let's say hydrogen gas. This interaction creates alpha, beta, gamma radiation, which cause the ionization of hydrogen. So we've got plasma, and this plasma goes to the center of the reactor. So that's my understanding at the moment. I don't know if it's completely correct, but that's my understanding.
Thank you very much.
Actually, regarding the nano coating, we would like to prepare some more information. We already uploaded some videos on our YouTube channel and added some description to it to make it more easy for all of us. And maybe we can prepare some documentation with step-by-step instructions, but it takes some time. We are quite busy in the lab, so we can make it later maybe. But we try to be as open as possible and as clear as possible. So if you need some clarification, just ask us and we can later add it to some documentation and extend it.
And I'll send you some pictures later, more pictures actually, and videos too, if the connection will allow.
Anyway, process of the coding, it was very clearly explained in the Fukushima workshop, and you just have to follow these instructions. And we also posted some videos on YouTube channel, on Spaceship Institute YouTube channel. So it's pretty clear and easy procedure.
As I said, we can always make clarifications if necessary.
I'd just like to thank you guys for making yourselves available for all of this and not, it's easy to sequester the information and so on and so forth. You're being open and allowing it to happen and to provide that continuity for us. We're very thankful, especially this workshop just is going to open everything right up. It's great. Thank you.
This is the best workshop you get today.
Is there a channel to ask questions to the knowledge seekers?
We do that every time.
The forum.
Workshop I heard, the best workshop I heard. And then the next one. This is just the beginning. Just the beginning. Workshop
So,
like this is going to be every week.
Besides the forum, is there another
Find
channel?
We have Facebook, Spaceship Institute page. It's our main source for now because we have to somehow figure out how to run the forum so that it will be easier and faster in response. So for now, the Spaceship Institute Facebook site is the official source of information from us. And together with the YouTube channel, Spaceship Institute, this will be the main source. And we can then somehow bring for better usage, but it needs some time and clarification how to do it.
As you create your own website, download the information from Spaceship Institute and just post it in there.
Yes.
For example,
your own videos.
I have my Mr. Fix-It Rick YouTube channel, and I'll have a video of this work as well as the 10th workshop of last week should be available within a couple of days or so. So, and then those videos will also be posted to the Keshe Foundation main YouTube channel as well. So my channel is Mr. Fix-It Rick. That's MrFixitRick, all one word. And folks can find the previous workshops on that channel as well. There's a playlist of them. And tons of information.
Yes, really. Thanks. I've already added a link to your channel to our Spaceship Institute Facebook page, so people can find it.
Yes, and also
you do your own videos, post it.
Yeah, we can search for it.
Experience. We need to learn from you too.
We are all knowledge seekers.
Yeah.
we are all seekers and all movie makers at the same time.
Yeah. For now. Rick, for now.
Well, summer movie
Hollywood game.
Say again, let me know, I missed that.
That's part of the Hollywood game.
Well, some are movie makers and some are movie stars, so it takes two to tango. Right now we have the stars of the Spaceship Institute, and hey, that's a pretty good saying. And the stars of the Spaceship Institute, get it? Must be something, a commercial you can make off of that. Okay, so is there any other questions, or shall we continue or not here?
I have one thing to add. Maybe if some of you have the possibility to prepare some good working site for knowledge sharing, it would be also good help for us. Let's say use teaching software where we can more easily share the information, because the Facebook is not so clear, and all the posts just get lost easy. So
you could start.
Actually, if any one of can do the job of preparing good site for sharing knowledge, be a big help for us.
Actually, I'm already working on that with some other people. I'm just getting different opinions on different software, and there is some free or very little cost software out there that does a very good job. So I'm just trying to look into how we could use that as that teaching classroom, and then also available afterwards, just like the workshop here. One of them is the big blue button, and I'm doing a little bit of research on that one.
I have seen them for.
And there's also the new live stream they call new.livestream, and it's a little different format than the old live stream, and it's more active. You can upload files more interactively and so on. It could be another option possibly. You have to pay $50 a month for the proper use of it, or else you get ads and all kinds of other annoying things.
I will check into it too. One of the team member in China, he operates a server, so maybe he can set something up so that all the knowledge seekers can post your material on it and can be accessed by anyone else around the world. I'll ask him if that is feasible or not.
It would be good to consider having backup systems like that all over the world, and if one goes down for some reason or another, we have others that are automatically available for people to still download the documents and pictures and videos. So it seems like a good idea to be able to repeat the sites, but at the same time, you want to tie back as much as possible into the actual Keshe Foundation or Spaceship Institute sort of official sites as much as possible too, to keep the exposure up for them and help promote those particular sites rather than links to all the other ones, let's say. So it's sort of two conflicting but still mutually reconcilable objectives, you might say. Okay, should we let the knowledge seekers seek a break here now?
Or do you mean get to work?
Right. Some of us go to sleep, depending on the world right now. Okay.
Have fun, guys. Don't party too much.
Like they got time to party.
I know they will, at least at the finishing list. Bye, guys.
Thanks, guys.
Yeah, thank you very much.
So thank you.
Thanks, everybody.